Hello, this is Jerry Stafford with my final project video. Yes, after all those explainer videos, we come to my final project. And it's a game called Black Box. Now, unfortunately, my program isn't totally functional. I have a lot of the game board written, but let me go over what the rules are supposed to be, and then we can delve into my program. So I made up this little diagram in Excel, and it basically shows the game board. It's an 8 by 8 game board, a lot like a chessboard. And the point of the game is to figure out where these atoms are. These will be hidden from the players. So either a second player has the atoms on a card of their own, or in the case of a computer game, they're programmed in. Um, or the computer itself can like randomly generate some atoms. But the whole point of the game is the first player has to figure out where these atoms are, and the only interaction that the player has with these atoms is by shooting beams into this black box. The beams come in directly perpendicular to whatever position they're fired from. There's 32 of them. They basically correspond to each row and column. Um, so if you fire a beam from position 1, you would get a hit. If you fired a beam from, let's say, position 4, you would get a deflection because the beams uh, don't want to be adjacent to an atom either. They can either directly hit or they'll deflect away from the atom. Uh, in this case, the beam gets redirected back to uh, position number 5. So from the player's point of view, if you fired from 4, all you would see would be a marker on 5 saying that it deflected there. And then there are reflections where a beam is deflected back into its starting position. And this can occur two ways, either through a circuitous route like this, or if you get deflected on the edge of the board. That's sort of a special rule. It gets reflected back if you deflect at the very beginning of the beam propagating from the edge of the board. So those are sort of the basic rules. Scoring is kept by how many beams you fire, and then how many guesses it takes for you to figure out the true position of all 5 atoms on the board. So with that in mind, let's take a look at my code. So far, I've gotten a lot of the buttons in there. Not all 32 of the firing buttons. I got a row of 8. I just wanted to make sure that that I got them all in the right place, and that's about all I have going. Even though it looks like quite a bit of code, when you actually compile and run this, it's a pretty basic board so far. I just kind of have placeholder code to say that yes, this button was pushed, but they don't actually do anything at this time. You see the iconic black box board, and you see one row of buttons along one side. Once this is fleshed out, you'll have rows of buttons going all along the perimeter. This is actually quite a fun game in real life. If anybody ever wants to, play a board game that's kind of scientific, it's a little different. This is definitely a good one. I don't believe it's being published anymore, um, you know, but you can find used copies of it on eBay, and it's quite a fun game, I would say. Too bad I didn't get to finish this project. I think it was a little ambitious, but c'est la vie. That's how far I've gotten so far. Okay, well, have a great rest of your lives, crew. It was fun working with you here in Computer Science 190. All right, goodbye.